Welcome to the DAU course, What is Artificial Intelligence, or AI as we call it throughout the course. We're glad you're here and excited to present online AI education for acquisition professionals. During your AI learning journey, don't hesitate to connect for questions, feedback, or even help with an AI mission. We promise the humans are still here at DAU, so hit up our software engineering team at agile@dau.edu, and we'll connect you with the right experts. With that, let's get started. Here's a course tip. AI is a data-heavy topic, even when you're just learning about it. To help you track the overlapping AI definitions and types, we have a course guidebook that will help with your notes, and it's a great tool to take back to your desk. To access the guidebook, stop the video and go back to your course screen in the Learning Management System. Click the hamburger menu in the upper left-hand corner of the screen, and click on Resources to find the guidebook. AI is everywhere, already playing an active role in our personal and professional lives. Facebook can now tell if two photos belong to the same person with an impressive 98% accuracy rate. In December 2022, the Air Force used DARPA-developed AI agents to fully and completely pilot 12 flights of the X-62A Vista, including advanced maneuvers. 97% of the world's smartphone owners already use an AI-powered voice assistant to help manage their busy lives. And OpenAI's ChatGPT took the world by storm in November 2022. The AI-based large language model garnered more than 100 million active users in just 2 months. And users were figuring out how to solve complex problems with ChatGPT overnight. No instruction manual needed, including writing resumes, coding software applications, writing research papers, and the cyber community used it to both improve cyber intrusion detection and develop malicious cyber tools. AI will transform DoD, our adversaries, and the battlefield. To give our warfighters and DoD support teams the best and most current technology available, the acquisition community must harness AI to advance our security and prosperity. This business-level introductory AI course is intended to help you manage or work on an AI program. Upon completion, you'll be able to define AI and navigate differing and sometimes ambiguous AI definitions, types, and domains, create a common lexicon to support productive AI business discussions, and ask probing questions to help cut through AI hype and identify whether a system might include AI technology. Before diving into AI, acquisition professionals need to know that AI is a tricky subject. This famous quote sums it up. AI is an enigma wrapped in a mystery, shrouded in confusion, and framed with misconceptions. Why is that? Well, some of the key reasons are topics for this course. The field of AI lacks structure and governance. There is no solid agreement on exact AI definitions, taxonomies, or types of AI, or exactly which techniques fall under the AI umbrella. Add to that, AI's tech jargon sounds like brain science, and with new AI capabilities coming at us on a near monthly basis, practice and guidelines to design, build, and test AI are well behind the technology. Recall that one goal of this course is to teach you how to navigate AI ambiguity. To get there, prepare to hear about multiple AI definitions and messy and sometimes confusing types of AI. It feels like they overlap, and you may wonder why we're covering them all here. It's because the only way to navigate AI ambiguity and make you a smart buyer is to teach you why things are so unclear, and you need a good sense of what all of those types and definitions are. A key takeaway for this course is, buyer beware of that AI ambiguity. It will be up to you and your program to decide how to frame AI for your project. Make your definitions clear in program planning conversations, with vendors, and in solicitations and contracts. As a buyer or builder of AI, take nothing for granted. Part 1 highlights the challenges associated with divergent AI definitions and covers the 3 definitions of primary importance to DoD. AI definitions vary, even among respected sources. This definition from Stanford University says AI is a branch of computer science that studies the properties of intelligence by synthesizing intelligence. Can you imagine putting that in a contract? It wouldn't solve for anything. And what is human intelligence, really? The truth is, science still doesn't fully understand the human brain or intelligence, so how can we use that in a definition? John McCarthy, one of the founding fathers of AI back in the 50s, said AI is the science and engineering of making intelligent machines, especially intelligent computer programs. This is one of the most oft-used definitions. What's an intelligent computer program? I have some very advanced Excel spreadsheets. Don't they perform intelligent tasks or tasks that normally require my intelligence? Yet they're not considered by most to be AI. Look at this definition from Russell and Norvig, authors of the quintessential textbook on AI called AI: A Modern Approach. AI is the study of agents that receive percepts from the environment and perform actions. These definitions aren't helpful for DoD. We need things to be more exact. Now, you don't need to memorize these definitions, but you need to know they're out there. Most AI definitions are ambiguous, and it's very common for vendors to define the AI in their product using these descriptions. Sometimes when you look under the hood of an AI product, there's really no actual AI technology in the system. AI capabilities aren't easy to create. In fact, it's estimated venture capitalists have invested billions in startups who said they were working on AI or said they had AI, but were ultimately unable to deliver it. Solid definitions matter, and the three in play for DoD are pretty good. The first AI definition in play for DoD comes from DoD's 2018 AI strategy: the ability of machines to perform tasks that normally require human intelligence. Still too ambiguous for us. However, there are helpful qualifying examples also in the AI strategy that are sometimes missed. If we add the examples to the definition, it gives us a much better sense of what DoD considers to be characteristics of an intelligent computer system vice a regular computer system. Recognizing patterns, learning from experience, drawing conclusions, making predictions, and taking action. Now we can start to build a picture of what AI is by asking, what's different about an AI-based system and a traditional software and hardware system? By the way, you don't need all of these characteristics at once to have an AI system, but you need a good number of them. Let's put this into context with a familiar use case from Netflix. We just learned that an AI system should do some combination of learning, finding patterns, making predictions, drawing conclusions, and taking action. That's what separates an AI system from a traditional software and hardware system. Streaming services like Netflix do that. They analyze and learn from data points constantly: customer viewing choices, hobbies, browser data, perhaps social or location data. And then they use AI-based machine learning to find clusters of statistically significant patterns in the data. The goal is to draw conclusions that uncover novel ideas, new things that a human wouldn't have seen in the data or that they didn't already know. Recommendations, new products, new ways to segment the business, or perhaps something completely unexpected. AI can analyze much more data than a traditional software system, and in a huge variety of algorithmic ways, and at a much faster rate than humans can. Netflix can also train AI models with adjacent data, so to speak. They'll try to find even more new patterns in data that they maybe didn't use before. Through a process of trial and error, they'll try things out like environment data, weather, internet usage patterns, what was going on at the time with current events and trends. They might even look at Reddit or Facebook conversations about movies and TV shows. Over time, Netflix algorithms continue to learn about customer habits, likes, dislikes, and what similar people do. And they use that to create new products and user experiences. In the end, once a viewer selects that who's watching profile, no two users will ever experience Netflix in the same way. Everything is personalized for us courtesy of AI. Check this out. The thumbnail they show me for the movie Good Will Hunting is probably not the same one they'll show you. Almost everything about the screen, the artwork, show descriptions, and how the show choices display are completely tailored by AI algorithms that have predicted what is most likely to appeal to us as individuals. You may not realize it, but Netflix is constantly A/B testing these things on users in production. Congratulations! If you have a Netflix account, you're also a Netflix tester. And there's quite a lot of testing happening. It's not uncommon for Netflix to have 20 or 30 image thumbnails for a single show. And all of the results just become more data for the AI algorithms. AI has taught Netflix that this works. Surveys show users are predominantly very happy, and their $32 billion business continues to grow. Netflix is an example of a product where AI capabilities matching our DoD definition are truly in use. These are the kind of things you want to look for at a vendor. If you find this use case interesting, check out how Netflix continues to experiment with AI at research.netflix.com. They share very detailed information that could be helpful to AI planners, developers, and testers. The second AI definition in play for DoD is from the National Defense Authorization Act of 2019, also called the John McCain NDAA. Sometimes people call this the John McCain AI definition. Keep this definition handy. As of early 2023, this one is most often cited by new statutes, policy, and guidance. It's the longest of the three definitions and the most helpful because it goes further to lay out several characteristics, or examples really, of what is meant by modern intelligent AI machines. I won't read the whole definition verbatim. I'll spare you that. But please pause the video to read through it or cover it in the course guidebook. It will be an exam question topic, and you need this definition because it's the most important one. The third and final definition of importance to DoD is from the National AI Initiative Act of 2020. Even though this definition is the newest one, it doesn't seem to be referenced quite as often as the first two. Don't discount it, though. It includes unique language to describe intelligent machines that could be helpful. It says AI uses both machine and human-based inputs to perceive environments, abstract those perceptions into models, and use inference to formulate options. Again, please pause the video to absorb or cover it in the student guidebook. Now you've seen the three key AI definitions listed in statutes and policies that are impactful to DoD. So which definition should be used? Great question. Well, the good news is our three definitions don't conflict with each other, so it's possible to combine them into a view that's even more helpful, really, in defining AI and understanding what makes an AI system different from a traditional software and hardware system. The combination gives us a terrific foundation of AI descriptors and characteristics. Take a look. This DAU tool merges key aspects of all three AI definitions into a fuller-fledged set of AI descriptors. The tool should help programs select appropriate high-level terms to both describe AI systems and AI capabilities. It should also support non-technical team members in asking probing questions to discern whether AI might be present in a system. The top row labeled AI system descriptors contains all of the system types mentioned in the definitions. Examples: intelligent software agent, or neural network, or cognitive architecture. The second row contains all of the AI system capabilities mentioned in the definitions. I think of these as the evidence that a system may be acting intelligently. Examples: perceives real or virtual environments, or abstracts perceptions into models, or uses model inference. Note: this tool is for reference purposes. Please refer to the actual definition cited for official business, legal, or contracting purposes. And please know there are many other descriptors that could be used for AI, so don't limit your team to these if something better works for your system. Our last topic in this section is the AI umbrella and the AI hype cycle. AI is called an umbrella term, and sometimes even a buzzword or a suitcase term. And the term AI is used to cover such a vast number of modern software and hardware development techniques. The common thread in all of them is that they attempt to mimic human intelligence or some other thing humans do in some way. We hope anyway. But, know this, there is nobody, no official list or governing body who controls or decides what falls under the AI umbrella. So which of these technologies or techniques are we going to say are officially AI, right? You have to go back to those descriptors in the definitions that we covered. New techniques emerge frequently, sometimes monthly. So AI programs need to stay abreast of new trends and threats. And AI techniques that we consider under the umbrella today are transient, meaning once an AI-based technology becomes commonplace, it tends to no longer be considered AI by the AI community. A good example of that is Google Maps. Another example back in the day was autopilot. A lot of people thought autopilot in airplanes was early AI, right? And now we don't think of it as AI at all. So it's really hard for DOD or anybody to come along and say, when you have AI, you shall, because it's hard to define, and we're not sure if the technology in 2 years will still be considered AI or not. So I prefer to think of AI as, modern software running on modern hardware with a lot of data. Here are some examples of techniques that are currently unofficially under the AI umbrella. And I'll just read a few of them. You don't need to memorize these, but some cool things we have going on. Robots as a service. Just when you thought cloud wouldn't produce any more as a services, we have robots as a service now. Non-visible machine vision. And that's where we're going to use the electromagnetic spectrum for computer vision instead of the sensors that we use today. So, or in addition to, I should say. Self-supervised learning. Our machine learning operations are having trouble, and not just DoD, but everybody, finding enough data that's labeled. We spend way too much time trying to label and clean up our data and don't have enough time to do the machine learning part of it. So we're looking for ways for machine learning to learn without us labeling the data, and maybe it spends some time in the beginning trying to label it for us. And also, when we don't have enough data, this topic of synthetic data is really hot right now. So here's one of those ones that sounds like brain science. I told you that a lot of these terms, neuromorphic computing. So I'll leave that one to you guys to look at if you're interested in it. Because AI makes headlines, and there isn't a solid definition of AI, and it's a buzzword that is used in a general and vague manner, the gray areas leave so much room for people to overhype AI. AI news, AI claims, AI products. So this AI hype problem is real, even to the point where Congress wants to ensure that acquisition professionals are aware of it, that when we train you to be smart buyers, that we train you about what's out there in terms of AI hype. So look out for AI products and initiatives that have very little to do with actual AI. And I hate to say it, but I've seen some. Someone will say, oh, we're doing this or this with AI. And I look and I said, what's the AI doing? And sometimes they think they're using AI and they're not. They're using data analytics or something. So, you have to be on the lookout for that. And again, those descriptors from our definitions are great. And when we do have AI in a product, look for misrepresentation of AI advancements. When we get into the AI types and I show you where AI is today, it's going to be a long time before we get to the next stage in those types where AI is completely able to do everything a human can do. But there's vendors out there saying they have AI in those categories. That is not true. That's AI hype. They're just using it to market it. So push back on those when you find them. Oh, by the way, I was going to say, next time you hear an AI story in the mainstream news, now that you know this, listen carefully. You're likely to hear either hype or fear-mongering or both. But what I'm always struck with is how little the reporter usually knows about the technology they're talking about. I mean, maybe do 2 minutes of research on it. So yeah, people love to do that, especially around ratings time. So for perspective, I recommend checking out these 2 recent articles on avoiding AI hype. And these come from the tech world and not the mainstream media. Spoiler alert, though, One of them talks about how Elon Musk hyped a robot on stage, and it didn't go well. The AI people in AI robotics thought it was a whole lot of fluff. So even our tech leaders can do this. So I know you can't access these links through the video, but just search the titles, please. You'll find them. And as of today, neither of these articles is behind the firewall. Here are the key takeaways regarding AI definitions. 2 things to keep in mind. 1, I won't read them to you here. Please stop the video and read the screen or consult the course guidebook or transcript. And 2, please pay attention to the notes associated with the key takeaways. It's really not possible to put everything you need to know about AI in the key takeaways. You'll need to go back and look at what we've covered. The next section addresses 3 ways to think about types of AI or classifying AI. This refers to how advanced an AI technique or AI system is. Method 1 is AI classified by level of intelligence when compared to human intelligence. Method 2 is classified by likeness to the human mind. It sounds similar to Method 1, but there are differences between human intelligence and the human mind. And Method 3 was created by DARPA, and it classifies AI by a computer's ability to process information. Why do you need to know 3 ways of classifying AI? Well, by now you won't be surprised to hear there is no official way to classify AI systems. When you research AI, you may find the 3 types of AI, the 4 types of AI, the 7 types of AI, or more, and they will use some of these interchangeably. Vendors may make statements about their AI capabilities and may reference any of these methods and sometimes mix and match them. A vendor may say something like, "Our AI product is approaching AGI level. We are well past limited memory AI and into the theory of mind AI." Smart buyers need an awareness of all common ways AI is being classified today and some knowledge about where the world is at with AI advancement. As we start to learn about the types of AI, there's a key aspect of AI that has the potential to cause program issues down the road. And you'll need to be aware of this when you see how we type and categorize AI. Anthropomorphism, the attribution of human traits, emotions, or intentions to non-human entities. In other words, to humanize something that isn't human. Examples of anthropomorphism are this rock star cat I'd like to hang out with, putting a human face on the sun, and Tom Hanks in the movie Castaway putting a human face and hair on a volleyball and naming it Wilson to keep him company on a deserted island, and all artificial intelligence is anthropomorphic. This is Sophia, the humanoid robot, actually on the cover of Cosmo. Sophia is the first robot citizen of the world, the first robot to have a credit card, and was named a United Nations Robot Ambassador, so the first non-human to receive a UN title. I would say the world has most certainly anthropomorphized Sophia. By the way, facial expressions and interpreting emotion are Sophia's claim to fame. What do you think of her mad face? Kinda creepy. A couple of years back, Josh Marcuse, former executive director of the Defense Innovation Board, did a great DAU webinar on AI. I'll put it in the resources. He was concerned about this topic, saying that anthropomorphization is the flaw of treating AI as if it's a human-like in its qualities. So even though AI is anthropomorphic, and it wouldn't be AI if it weren't, we need to be careful not to start thinking about or treating our systems as if they have those human capabilities. It happens. It can be a problem. Be aware of these potential program issues associated with anthropomorphic thinking. The first one is the fact that the majority of AI research and development focuses solely on the pursuit of those human-like characteristics. Everybody's trying to get that human-like brass ring. But instead of focusing so much on that and trying to engineer human-like capabilities and a lot of times doing a pretty bad job at it, we should focus on examining everything the technology can do, which in some cases are things humans could never do. So let's not overlook that opportunity and sell the technology short by limiting our thinking that it has to do human stuff. Anthropomorphic thinking may influence the way our teams design and decompose systems. I don't think this will be a problem at DoD because we're really good at designing and decomposing systems. But it's been a problem elsewhere. So system actions need to be composed and carefully mapped to their algorithmic and sensor counterparts, and we know that, not their human parts or capabilities. When we view technology through an anthropomorphic lens, we risk limiting our thinking from a planning, engineering, and testing perspective to the way humans do things rather than the way the systems do things. And this one's more for program managers, but when we humans think something might displace or replace us or a machine might hurt us, we react with fear. It's pretty natural. And we didn't worry much about that when spreadsheets came out or Google gave us navigation help. Those are software tools without a face, and we were glad to have them. Well, AI is software as well. And yes, it runs on hardware that might be robotic or autonomous, but most of AI does not run that way. It's an evolution of those same computing techniques. And we aren't nearly as far along with AI as sci-fi would have us think. So sometimes this fear is unwarranted. It may cause you program challenges, depending on what kind of AI you're building, in the form of extra public or legislative scrutiny, reactionary policy and statutes that may crop up quickly, those kinds of things. Now, not to say there aren't ethical and social implications of AI, there absolutely are, and we cover that aspect in another course. But while we're on the topic of Sophia, here's a short example, if you want to go watch a 2.5-minute video of where Sophia's causing some of that fear because she went off the rails a little bit one day. Now on to types of AI. There are multiple ways to classify AI technologies, and depending on the researchers, expert, or vendor, they may use different systems of classification. We'll cover 3 common methods, and I recommend you use the course guidebook to help follow along, as this part of the course is a bit heavy on data, and you'll need this for reference later anyway. The first method is to classify AI broadly by likeness to human intelligence. This is a common anthropomorphic way to categorize AI advancements. Within this method, there are 3 levels, sometimes called the 3 waves of AI. The first wave is narrow AI, which is inferior to human intelligence. The second wave is general AI, which is equal to human intelligence in every way. And the third wave, super AI, theoretically will surpass human intelligence. Our current stage of AI advancement is toward the latter half of the narrow AI wave, shown here in the shadowed area. For the record, the world's AI advancements are still solidly in the category of narrow AI, but there are some who feel we're starting to lean into capabilities that feel a little bit closer to general AI. It's not really true, though. We are nowhere near general AI yet. Each wave, unfortunately, has multiple names used by the AI community, but we've listed them all here for your reference in an effort to further help you manage the AI ambiguity challenge. Narrow AI is also known as first wave AI, applied AI, weak AI, or ANI, artificial narrow intelligence. ANI is characterized by tasks that perform a narrow or specific function. Examples are speech recognition or autonomous driving. And while they seem like big fields unto themselves, they're still very solidly in narrow AI. Narrow AI exceeds human-level efficiency, but it's not equal in any way to human-level intelligence. Today's advancements and focus are on learning, perception, cognition, and generalizing pattern recognition, so just in alignment with some of those descriptors in our AI definitions. The last 10 years or so of advancements have been spurred by readily available computing power. So the onset of cloud and being able to get computing power on demand, and some of our faster chips, GPUs and such, have really made a difference in our advancement in the last 10 years. Some examples of narrow AI are Siri, Alexa, ChatGPT, image recognition, and everything else we have that's AI today, because there is no other kind of AI, according to this categorization, than narrow. General AI is second wave AI, or strong AI, or AGI, artificial general intelligence. AGI is theoretical and it would be AI that meets human-level intelligence in a way that can be generalized across many scenarios, hence the general AI. Currently, this is a subject of quite a bit of research and development, as we said earlier, and current AI is nowhere close to general AI. Computing hardware, though, is becoming advanced enough for AGI, or so we think anyway. The holdup for AGI is really that we would have to make computers sentient, fully sentient and emotional in order to reach this stage. So while sometimes it feels like we're tiptoeing into it with certain things, and maybe we are, maybe narrow isn't sort of big enough to hold how well we're doing there, but we're certainly nowhere near sentient and equaling the intelligence of a human. Super AI, also called third wave AI, sci-fi AI, or ASI, artificial superintelligence, is really theoretical. It's AI that is significantly more intelligent than the best human minds in almost every field, including scientific, creativity, general wisdom, and social skills. It's equal to singularity. If you've heard of technology singularity or technical singularity, it's a hypothetical future where super intelligent AI will have surpassed human intelligence. Okay, here we are at AI classification method number 2. Stick with me. We only have one more after this. I know it's data laden. Remember, you're learning about this, so you have an awareness of this foundation, because some of your vendors might use method 1, 2, or 3, and you need to be able to sort of speak the same language. The second AI classification method is also anthropomorphic. It classifies AI by likeness to the human mind. Sometimes it's called classifying AI by functionality, and that means functionality of the human mind. The 4 types of AI here are reactive machine, limited memory, theory of mind, and self-aware. So you can sort of see the spectrum of the human mind development. The current stage of AI advancement within this model spans types 1 and 2. So we're within reactive AI and limited memory AI, shown in the shaded yellow area. Reactive machines, number 1, is the most basic form of AI. Reacting, you can tell by the name, it's reacting to its instructions and its input. Very reliable, very task specific, very basic. Examples are text preparation software or IBM's Deep Blue chess playing supercomputer. It understood chess pieces, it understood the chessboard, and it understood all the moves chess pieces could make. And from that, it figured out how to beat Russian Grandmaster Garry Kasparov. It couldn't do anything else, though, and it couldn't transfer that knowledge to any other system or problem, and it couldn't remember anything from the past. So it didn't remember its best games or anything like that. Very basic. The next one, number 2, is limited memory AI. And this is really where we're spending a lot of our time today. This is where the modern AI advancements are happening. It contains usually a pre-programmed representation of something. In the case of self-driving cars, it's kind of the pre-programmed representation of the world where the car will be driving. So it understands maps, lanes, directions, things like that. These systems have a fairly short-term memory that allow them to temporarily store acquired observations and data so that they can take action on them, right? So they're combining what they're observing and acquiring with their pre-programmed representation of the world. Previous experiences usually are not kept, and because these systems have a limited memory, although I understand Tesla is starting to keep more and more of them and send them back to the home office and whatnot so they can learn more about self-driving. Number 3, theory of mind AI. It's a theoretical type of AI that understands humans. In psychology, theory of mind is a social cognitive skill that involves the ability to think about the mental states of yourself and others. So it includes emotions, desires, beliefs, knowledge, and recognizing that other people's thoughts or other agents' thoughts might differ from yours. So this is exactly that. It gets its name from that stage in psychology. And as conceived, These machines would form their own representations of the world and then assess the goals and potential goals of others. It'll socially interact with thoughts and emotions and other agents. You know, we have done partial work in this area, so there's a couple of partial examples. One is Kismet. That's an older robot that's been around for a while. Actually, I don't think it's around anymore. It could recognize facial expressions and replicate them back. So that's how you knew it recognized it, because it made the same facial expression back. Pretty advanced for its time. And the more modern one is Sophia. Sophia is a humanoid robot, meaning a robot that looks very much like a human. You can still tell. But through her eyes, she does image recognition, and she responds to interactions with the appropriate facial expression. So there really isn't any theory of mind going on with these machines yet, but it's felt that they're beyond number 2, limited memory. So starting to tiptoe over into theory of mind. Perhaps we should, move our shaded line just a little bit over to theory of mind. And the last one is self-aware, and that's fully conscious AI. And similar to number 3 in the method before, we are nowhere near this. It's pure science fiction. It's the most complex form of AI we can currently imagine. It's completely theoretical, but these machines would have human-level consciousness, understand their own needs, predict feelings of others, and the only examples we have really are science fiction. So the character Data in Star Trek is mentioned frequently, HAL 9000 even from 2001: A Space Odyssey, and Skynet from the Terminator series. So those are the best examples we have, and a lot of times that's where we get them from until there's something real. And so those are the 4 types of AI related to method 2, which is AI classified by likeness to the human mind. Okay, our third and final method for classifying AI comes from our very own DARPA, and I think this method is the most interesting and the most well thought out. Also the most real, like you can wrap your head around it a little better than the other ones. DARPA wanted to focus more on what machines can do, and I think move away from pure anthropomorphic classification. So method 3 classifies AI by a system's ability to process information. DARPA said, let's classify computing systems by their ability to process information, and then we'll talk about intelligence capabilities in relation to a human. So there's a little anthropomorphic piece there, but DARPA's classification system has 3 waves. Wave 1 is handcrafted knowledge. Wave 2 is statistical learning, and wave 3 is contextual adaptation. And rather than exist as standalone categories, DARPAs are meant to be combined and built on one another. And you'll see in 1 or 2 cases where, wave 2 has a little less functionality than wave 1 even. So it's not a linear progression. Okay, let's take a look at wave 1, called handcrafted knowledge. And these are AI systems that describe. According to DARPA's intelligence factors, wave 1 systems are somewhat low on the perceiving scale. They don't learn, they don't abstract, and they're pretty darn good at reasoning. And some examples of those systems are tax preparation software, planning and activity tools, and chess. So it's starting to sound a little bit like reactive machine AI from the last method. The way these work are humans code all their domain knowledge in as rules, and the computers study the implications and present answers. It's good at logical reasoning. The computer works through concrete facts, if-then logic, Boolean logic. It reasons well over narrowly defined problems. It's not good at seeing or perceiving the outside world. It's not good at learning or abstracting knowledge and applying, to other levels or other domains. So very similar to reactive machines in the last example. DARPA Wave 2 is called statistical learning, and these are systems that categorize, and they represent the time frame on these as the present. This is the present. This is where we're at right now. And examples are cyber attack modeling and chat GPT and speech recognition and face recognition. And in terms of the intelligence factors here, it's a lot better at perceiving than wave 1, as well as learning. It's a lot better at learning than wave 1. And it has a little bit of capability now to abstract, whereas wave 1 didn't. But it's gone down in the reasoning category. So wave 1 was much better able to reason. And these systems, which is primarily where machine learning lives, in wave 2 here, statistical learning, where we're at right now, they don't have a lot of ability to reason. So this wave is characterized by humans that code statistical models for specific problems. We're talking about machine learning models. And we provide a lot of big data to the system, so it needs a lot of examples to learn from. It's good at nuanced classification. It's good at prediction and perceiving the world, learning from large data sets, sort of like the Netflix case we looked at earlier. It's not good at context or reasoning or explaining what it does, or learning with very little data. So a challenge with these, by the way, is sometimes they're statistically impressive, but individually unreliable. That means that they can go on for a long time and create amazing results. In fact, that happened to me when I used ChatGPT. In the beginning, I was just blown away. And then once or twice, I got these really crazy answers from it that just seemed out of character. I know I'm anthropomorphizing ChatGPT, but I just thought, what's wrong with it today? It was very individually unreliable at times. So I got some very skewed data, including it made up an entire illustrative history about my husband's uncle. I was asking it some genealogy questions, and I was sort of blown away, especially since I had had so many great responses for a couple of months beforehand. So DARPA says that a challenge is that while machine learning is statistically impressive, it's individually unreliable, and skewed training data sometimes creates maladaptation. So we have great ability to categorize here, but not good ability to explain. So it won't surprise you that wave 3, which is contextual adaptation, is all about explaining. And this wave is seen to be in the future, and there's no examples yet. They're theoretical. Now, DARPA's had a big XAI, or explainable AI, project going on for a long time, and DARPA's usually pretty good at these things. So the fact that they're saying this is the future and it's not here yet leads me to believe that this is a whole lot harder than I might even think. And I probably need to do more research in this area. Now, if you look at the intelligence factor here, which is what I'm calling it, perceiving is still up there, about 3/4 of the way across, and learning is up there as well still. And abstracting, we've gained, we're now at about 50% of the scale, but reasoning is back up to 3/4. So these systems are pretty balanced and well-rounded in DARPA's eyes, and humans will code contextual models instead of statistical models. So we'll be telling the system how to apply context, and giving them ways to figure out context on their own. They'll learn and reason as they encounter new tasks, and they'll require far fewer examples for training. So I keep reading about how you can do machine learning with very little data now, and I find it pretty hard to believe, but it sounds like once we get to wave 3, that's what DARPA expects as well. It may use generative models to perform abstraction. I'd be curious to hear what DARPA thinks after ChatGPT and everything that happened when we introduced that generative model to the world. And it'll be able to synthesize new data, and it'll have natural communication between machines and people. Wow, that sounds like theory of mind AI in the last model. So there are comparisons you can draw between these 3 models, but you're just never sure exactly which phases or waves equate to each other. I don't think any of them are perfect, but there's a few that are pretty close. So this is the DARPA Method 3, classified by a system's ability to process information. I want to point something out. DARPA has a great 16-minute video on this. So if you would like to see their perspective on AI, or you want to hear it from DARPA, there's a URL down below here, or just Google DARPA perspective on AI. It's a great video. Here are the key takeaways. regarding AI types. Please stop to read them or consult the course guidebook. There's a recap of all key takeaways at the end of the course. Part 3 deals with the domains of AI, or the groupings of AI techniques by common function, if you will. We will briefly cover mapping AI techniques so you can create your own domain map for your program. And we'll talk about 6 commonly stated AI technique domains. Now, I say commonly stated domains because you won't be surprised to learn that there is no official domain listing for AI tech. Many different organizations have views on it. And most of the time it's done anthropomorphically by how a human does things. So let's take a look. AI is complicated. One of the easiest ways to think about the incredibly complex world of AI techniques is to map them into domains by what a human can do. Take a look. Humans can speak and process language. So we have the AI domains of speech recognition and natural language processing. Humans can see and process images. So we have the AI domain of computer vision, which includes image recognition processing and machine vision. Humans can become subject matter experts in specific domains and make qualified decisions. Therefore, we have the AI domain of expert systems. Humans can put order to complex problems and continuously improve process. So we have the AI domain of robotic process automation. Humans can stand and move about and perform physical actions. So we have the AI domain of robotics and autonomous machines. That includes physical motion manipulation, sensors and actuators, and robotic software. And humans can learn and comprehend. So we have the AI domain of machine learning. That includes learning paradigms that learn like we do, in supervised ways, unsupervised ways, and when reinforced. Humans have statistical models. They're able to create them in their head to do classifications and predictions. And humans have neurons and layered processing. So we have an AI domain for deep learning on neural networks. This is another way to create a common AI language for your team and partners. Because we lack official AI domains, you can map pertinent techniques to your own ideas of what a human can do that makes sense to your team and your colleagues. Collaborate with them so everybody buys in. By the way, this exercise was inspired by my brilliant friend, Dr. Raj Ramesh. If you have 6 spare minutes, I recommend checking out his original video called What is AI for People in a Hurry? AI domains. This is our last data-heavy view, so please refer to the course guidebook again to help with your notes. And thank you for staying with us. I hope you took a little break in between. Because we will pull this all together. I know this is a lot of information, and this first course is like this, and the rest of them are not like this. So AI domains, we finally get to talk about some AI and what it does. We will review a sampling of 6 popular AI domains. And as you've heard, there are many more domains and techniques, and not everybody will agree that these are purely AI. And it doesn't matter for this discussion, though. But keep in mind, all of these domains and techniques are algorithmic. Algos are software, and AI is virtually always a form of advanced software running on advanced hardware, whether it's an advanced computer, an autonomous machine, or a robot, using and creating data. So there's commonalities here between all of them as well. So the 6 domains we'll look at are natural language processing, machine learning, computer vision, robotic software, expert systems, and robotic process automation, or very commonly called RPA. If you keep your eye on the bottom row, if you can, where it says DOD Defense, the examples that I put in here all apply to something that's happening in DOD or in the defense industry, so that you get a chance to relate DoD to these examples. We are going to start with robotic process automation on the far right. Now, this is an area, this is the one that's controversial. There's a lot of people, including myself, who feel like RPA really isn't AI anymore. There's several reasons for that. One, I think that, business process automation, people, product makers probably hijacked this category a little bit, and everybody started calling their regular business process automation software RPA because it was cool. And I see a lot of times RPA is joining with some sort of AI product and providing an integrated solution, but I don't see a lot of the AI in the RPA anymore. So I apologize to any vendors who hear this if you have one, but I just feel like it's not quite as prevalent as it used to be. But the definition here, and by the way, there are no robots, actual robots like Sophia robots or involved in RPA, almost never. I mean, I think there are some people who say they have a few robotic arms or something somewhere along their workflow, but this is really intended to be business workflow. Think of it as, workflow for defense business systems, for instance. Computers emulate and control and improve human activities and tasks. So it's workflow, it's optimizing, workflow processes. Software robots in quotes, they're not robots. It's software. That drives me crazy. But they automate routine tasks. So much of this is not really AI. It's on the list. And I know that this is the area where DoD has probably the highest number of systems considered to be AI. DLA has implemented a lot of these RPA systems. So I don't want to say that theirs aren't AI because I don't know for sure. They may be. Maybe they have that running in their product. So I don't want to discount that. But RPA on its own as an industry, I think they hijacked the AI terminology quite a bit. In DoD, we use this a lot for logistics, for workflows, operational processes. Financial management is big for RPAs, approval systems, and anything where we have humans. Army, I know, has people who used to have to enter data around the clock. They had 2 or 3 shifts. They're using this now to do kind of 24/7 data entry. So RPA is sort of known for automating a lot of tasks that humans don't really want to do anyway. So that's RPA. The next one is expert systems. And that's where computers mimic human experts in key domains. And so you see the little diagram here, the expert guy is on the right. And there's really sort of 2 parts to these systems. There's a knowledge base represented by the KB here, and that's the experts, that's what's in the expert's brain, expressed as facts and rules. So it's one of those systems where we're giving it everything it needs to know that the expert has. And then we're letting it do the AI part around that. The second part of it is called the inference engine. And I think if you recall, one of our AI descriptors from our definition said the machine would do inference, right? And so here's an example of an AI domain where that's happening. So we have this knowledge base or this data base of expert knowledge on any topic, right? And all the facts and rules that go around that. Tax reporting is a good one. You could use that again. And then we have inference engine. So it applies the rules and the known facts and looks at what's going on in the environment and produces new facts. So we really do have AI running with some of these expert systems. And what they're used for is expert reasoning, diagnostics, decision support. In DoD, if you look these up, you won't find a whole lot of, we're using expert systems, because I don't think they call it that. But I dug around and we're using it a lot for mobilization, and in a lot of our education groups around DoD, we're using expert systems to try and help us with education. Okay, robotics software. So this one, I went out of my way to call it robotics software. You may have noticed on the map we drew on just the last piece right before this, I had robotics and autonomous things. A lot of times the robotics folks who spend a lot of time working on that hardware and that mobility don't feel like they belong in the AI category. And maybe they don't. But the software that runs the robots absolutely belongs in the AI category. So a lot of people now are saying robotics software instead of robotics. I'm not sure how many people want to split that hair or whether it matters, but I thought I'd give you both views. So this is software that enables robotic machines to assist humans. And the idea is that eventually you get to the point where there's minimal intervention, that this robot can operate fairly autonomously. So it's another kind of autonomous machine. And there are degrees of autonomy that these folks are going for when they create these systems. And there's kind of three parts to the system: perception, which are the sensors, and in a lot of cases now today, the LiDAR. And there's the planning part. How is the robot going to create and execute a plan? And a lot of times they give the robot the plan, and the robot figures out how to execute the plan. And then there's the control piece, so controlling the motion and the actuators. So we're dealing with sensors and actuators here, and the software is really quite complex. DoD is using that. Just a few examples: combat support, search and rescue. VA is using it for vision surgery, robotic submarines, firefighting, robotic firefighting, and ordnance disposal. So sending these robots into areas where it's very dangerous for humans to go. So that's robotics software. It's a fascinating area. Next one is computer vision. Computers interpret, understand, and analyze the visual world, right, in all ways. And so this is a massive domain of AI, and it's very complex, very difficult. The other thing I should say now is that almost none of these, especially the ones once you get past RPA, are working alone. So for instance, computer vision makes huge use of machine learning, which is another domain. Natural language processing uses machine learning. And so these things are usually working in conjunction, and that's another thing that makes these domains, kind of the thought of them, sort of muddy. Computer vision has underneath it, it owns object recognition and facial recognition. So there's that going on. And I won't dive into the complex world of computer vision here, but it's a very hot area, obviously, for DoD. ISR, medical scans, augmented reality, maintenance assessments. We're using it to look at planes and ships and things like that, where it's hard to assess. You send a drone out, take pictures, make assessments whether maintenance is needed. Pretty cool. Targeting and autonomous machines. So any kind of autonomous anything is making big use of computer vision. Robotic software. You saw earlier Sophia's eyes, she sees through her eyes. That's where her computer vision is happening. Good place for it. But obviously they're using quite a bit of robotic software and machine learning with that. Okay, and then machine learning is the next one. And this is the hottest area of AI right now. So almost everything you hear about with AI in terms of people buying it or starting to think about working on it, they're probably talking about machine learning. Now, deep learning and neural networks are a form of machine learning, so they live inside that domain, but they're a whole different world unto themselves. And so I could have put them on here too, deep learning and neural networks, as their own domain. And that's really, when we talked about the Netflix use case earlier, that was all machine learning. That's algorithms that enable computers to learn from data without explicit instruction. And you can learn in various different ways. We have algorithms that will enable the computer to learn on data in different ways. And then we create statistical models from that. Because this is such a popular topic, I have a class just on machine learning, which this one is SWE0056. What is machine learning is SWE0057. So I recommend you take that one if you're getting it all into machine learning, and that's an introductory class for primarily business folks. And what we're using machine learning for is a lot of things, but machine learning is good at looking at massive quantities of data and seeing things we don't see, right? So is there something happening in the cyber world, for instance, and some kind of attack pattern that is happening that we just haven't noticed? I know when I used to work in banking, we used to get hit every Wednesday morning, but we didn't really know it until we started talking to other banks, and they're like, yeah, we do too. So we had to figure that pattern out ourselves. And so it's much more complex than that, but we're using machine learning to look for different cyber attack patterns and come up with what might work in terms of offensive cyber. Logistics, how can we reroute things and do things better? Machine learning is very good at looking at patterns and trends. Scenario analysis, we're DOD, we're big on looking at scenarios and con ops and what's going on. And machine learning is really good at looking across lots of options that we can't normally consider, maybe just being humans. Threat modeling, same thing. Diagnostics and maintenance. And I know we're using it for personnel to try and figure out, who's probably going to leave the military anytime soon and those kinds of things. So they're trying to look at it for headcount. And we're using this in education as well. And then the last one is natural language processing, NLP, and that's where computers learn to understand, interpret, and generate human language. Similar to computer vision, this is a massive domain of AI. There are several subdomains, very technical subdomains in both of those. And really, natural language processing gets into the structure and the meaning. Optical character recognition lives in there. Speech recognition, speech to text, and text to speech lives within natural language processing. We use that for automated intelligence, translators. That's huge for DoD. Chatbots. We have one at DAU. Virtual assistants, surveillance, voice activation for covert ops, so that they can be doing what they're doing and they're using their voice activated comms. Transcription, another big thing. So you can imagine for ISR that natural language processing is a big deal. It's not limited to English, by the way. So anytime we're hearing language or speaking language digitally or interacting, you're going to have natural language processing in there. So those are 6 common domains of AI. If you are just starting your first AI project in DoD or thinking about how you can apply AI, you're going to land in a few of these initially, guaranteed. So, if you'd like to do more research in these areas, it can't hurt you. And our other classes go into them a little bit more. So that's 6 common AI domains, very high level. Here are the key takeaways regarding AI domains. Please stop to read them or consult the course guidebook. Key takeaways are recapped at the end of the course. In Part 4, we wrap up with a brief look at recognizing AI systems. We'll look at AI context, applied AI versus foundational AI, and recognizing AI, how to discover whether a system may have AI capabilities. Recognizing AI. The first thing I want to tell you about is really more of a tip and not much of a learning objective, but I think it's important and it might help you. It is so important to recognize AI context in conversations. And there are really 2 contexts for AI, and everybody gets them confused at one point or another. The first one is the fundamental AI context, and that's something we acquisition people, we do for an AI system, or an AI product, or an AI project. Examples: contracting for AI, engineering for AI, testing for AI, program management for AI, and so on. Logistics for AI, right? For an AI system. It's like saying software, right? The second is applied AI, the applied AI context. And this is where AI is being applied to improve a process or to solve a problem, right? So examples: AI for contract creation, AI tools for program management, AI for software testing, AI for the logistics lifecycle, AI for advanced engineering. I mean, you name it. It's very easy to get these two confused. And even if you have it straight, the people you're talking to might not, especially if they go shopping, market research, and that kind of thing. You got to be careful. Furthering this challenge for us, though, is that applied AI solutions are plentiful. I would go so far as to say overfloweth. They're everywhere. There are AI products to fix every process we use in acquisition. And then some. I think seemingly everything on Earth, there's AI products. So if you Google something you need in acquisition, such as how to engineer AI, you will find an onslaught of products, white papers, and consulting reports on how AI can advance and fix your engineering process. And a lot of people fall for this and they start working on them thinking that this is going to help them figure out how to engineer AI. For example, on the other side, the fundamental AI piece, and we've talked about this, the guidance there, the policy there is way behind the technology. So you'll find you don't have everything you need. And take our other classes, we're trying to help as much as we can with that. But you're going to have this need to constantly search, and you're going to find applied AI instead of fundamental AI in a lot of cases. Now, I would say things are getting a little bit better because the world's starting to figure it out, but it's not great yet. So you'll be consistently caught up in this in one way or another. The last topic for this course is discovering whether a system may have AI capabilities. So how does a business person or even a technical person who can't get their hands on the system try to discover if a system really has AI capabilities? The answer is you already know, and you have a high-level solution. The AI descriptions from our 3 definitions covered earlier are perfect areas to probe, to formulate questions for vendors. And here is a quick system intelligence checklist that comes from those questions. And you can also use the DAU AI definition reference chart we reviewed earlier. This is a starting point. This is high level, but it'll get you pretty far. And if the answer to any of these, or all of these, I should say, is no, then the system probably doesn't have AI. And if the answer is yes, you can explore those areas in more detail. For guidance on how to do more detailed AI due diligence, how to run an AI project, those kinds of things, we have a few options. Visit the DAU AI community of practice. We also have a DAU course called SWE0061, Orchestrating AI Acquisition, or reach out to DAU for potential mission assistance. agile@dau.edu. Email us at agile@dau.edu, and we'll pass you on to the folks who handle mission assistance. Congratulations, you made it to the end of the video. You're a trooper. You hung in there through this. Let's do a quick recap of key takeaways before I let you go. And as you know by now, I won't read them all, so please pause the video or find the key takeaways listed in your course guidebook. Summary of key takeaways numbers 1 through 4. There is no single universally agreed upon definition of AI, method of typing or categorizing AI, or method of grouping AI into domains. Smart buyers should be aware of AI ambiguity and align team members, stakeholders, and vendors to the definitions and descriptions of AI in use by the program. The 3 AI definitions in play for DoD are from the DoD AI Strategy of 2018, the National Defense Authorization Act of 2019, and the National AI Initiative Act of 2020. The 3 definitions can be combined into a very useful chart of AI system descriptors. Use the DAU tool called DOD AI Definition Reference Chart to make your life easier. AI is often overhyped. High-level differentiators between a traditional system and an AI system are learning, pattern recognition, drawing conclusions, making predictions, and taking action. Summary of key takeaways numbers 5 and 6. Anthropomorphism means to ascribe human traits to something that isn't human. All AI is anthropomorphic, which introduces potential challenges and risks for the program. 3 common ways of classifying AI are AI classified by resemblance to human intelligence, AI classified by resemblance to the human brain, and AI classified by a system's ability to process information, which is DARPA's methodology. Summary of key takeaways number 7 and number 8. The 6 commonly accepted AI domains covered were natural language processing, machine learning, computer vision, robotic software, expert systems, and robotics process automation. Summary of key takeaways number 9 and 10. There are 2 contexts for conversations about AI systems. Fundamental AI is a process for an AI system. For example, systems engineering for AI. And applied AI is AI for a process or to improve a process. Example, AI for the systems engineering lifecycle. Non-technical team members can use the DAU AI System Intelligence Checklist or the DAU DOD AI definition chart to formulate probing questions to discern whether AI capabilities, or think of them as techniques, might be in a system or used by a system.